Hello, my name is Julius Csotonyi. I am a scientific illustrator and also trained as a scientist. And today I'd like to take you through a sort of colorful show of what I love to do in my life and explain to you how I use science to inform my artwork and also how I use the illustrations then to help boost the visibility of science to the public. Many of the people who are familiar with my work know that I do mostly paleo art, the depiction of creatures from long, long ago, but also I enjoy doing space art. And so I'd like to kind of take this in a different direction here to show kind of how the two kind of intersect in many cases. Two things have always been very dear to my heart. One is the natural world and understanding how it works through science, and the other is painting and drawing it. And right now, I get to do both of them in my career, so I'm very happy with that. Science is such a wonderful thing that can take us to faraway worlds, both in space and time. In many cases, we can't observe these directly, so illustrations actually help us to get there as well by visualizing what some of these places or times may look like if we can't directly observe them. My scientific training took me increasingly in the direction of the search for life even beyond Earth, because it is a life in extreme environments that is most similar to what we might find in other planetary environments beyond Earth. I started with the study of mutualisms, or the beneficial interaction between organisms such as yuccas and yucca moths, through the positive reaction of plant communities to trampling in Jasper National Park, and then all the way to the study of bacterial communities in, say, highly saline springs in Manitoba, and also these strange deep ocean hydrothermal vent communities off the west coast of Canada. The favorite part of my research involved the study of these deep ocean communities. It was a fascinating study, and I was lucky enough to be involved in three research cruises to these communities. And it is these deep ocean studies that resembled quite strongly the exploration of interplanetary environments as well. Both involve very hostile environments that would kill a human being if exposed, and both also involve these elaborate types of equipment that are necessary to access them, such as a large mothership and then either a remote operated submersible or some sort of rover. And we use this remote operated submersible called Ropos to access some of the marine communities a mile or so beneath the surface of the ocean. Deep ocean hydrothermal vents are fantastic places where water percolates into the crust and is superheated by magma close to the surface and then comes spewing out through the rocks, through fissures in the rocks at high pressure and temperature, and often laden with minerals, forming these sulfide structures called black smoker chimneys, named after the plumes of minerals that precipitate when they hit the cold water. And they can be up to 350 degrees Celsius, which is hot enough to melt lead and char wood. And yet, when we sample the surface of these structures within centimeters of these hot water spewing from these vents and culture it on microbial growth medium, we find life. We found many different kinds of bacteria growing in these environments, a whole community of them. Perhaps the most surprising component of the bacterial community at these hydrothermal vents is the photosynthetic bacteria. So even though the ocean at this depth is typically pitch black, hydrothermal vents are a place where there's an exception to this and can support these bacteria that use light to power producing their own food, just like plants do at the surface or similar to it. How does this happen? Well, I've used a series of illustrations here to help convey this idea. With the remote submersibles lights alone, we might see the view on the left here with just a plume of effluent containing smoke-like particles of metal sulfides in it, and the tube worm tubes around it. Now, if we were to let our eyes adjust long enough, we might see this faint glow emitted from the place where the water is coming out of the chimneys. It's the sort of the tail end of the spectrum of black body radiation that's emitted by the hot water. In fact, the water is so hot that it literally glows red hot, but it glows even more brightly in infrared light. So if we were to exaggerate the view and look at it, so to speak, from the perspective of the pigments that the bacteria use to transduce light energy to chemical energy, we would see something like the scene on the right, with the brightest glow in infrared coming from the place where the water is exiting and mixing with the cold ocean water. And so this is geothermal photosynthesis. This light, this infrared light, and then a little bit of visible light, is only useful for a few centimeters around the vent exit location, but it's enough to power bacteria's physiology. And this also illustrates an interesting way in which we can use scientific art to help convey some of these ideas to the public at places like this Huntsville Science Festival. So this illustrates this two-way kind of mutually beneficial interaction between scientific illustration and science. Scientific illustrators rely on science to inform our illustrations, not to just make attractive pictures, but to make them reliable scientifically so they can be used for education. But also, these illustrations can then be used to help boost the visibility of science to a larger proportion of the public, because images are very eye-catching and they help to make scientific studies more visible to the public as well. And in this sense, this interaction resembles the mutualisms between certain animals, like the ones that I'd studied actually, these yuccas and yucca moths, a pair of organisms in arid environments that depend on each other for survival. So the yucca moth is the only known pollinator of yucca flowers, and beautiful night-blooming flower. It deliberately pollinates them. And both creatures require the other for survival. The plant absolutely requires the moth to raise a new generation of plants. And then the moth also requires the plant because its larvae feed exclusively on the developing seeds, or some of the developing seeds in the yucca flower. So in that sense, science and scientific illustration also benefit each other. And I'd like to explain to you sort of both components of this interaction. So let's start with how scientific illustration is used to help the public become more familiar with science. There are a lot of different ways that I really enjoy using my artwork to help boost scientific studies in the eyes of the public, and I'm going to explain some of those here. A very large proportion of what I do involves creating press release images and figures for publications by scientists. So I love to do this because I still get to work closely with scientists, even though I'm now an illustrator. And most of what I do involves paleo art, or the reconstruction of living appearances of organisms that lived long, long ago, long before we had a chance to be able to observe them directly. And what I do then is I create images that the scientists then use in connection with the release of their publications, so that a larger proportion of the public is able to access the science that's involved. Because a lot of people aren't familiar enough with the field of science to read the technical publication, but combined with well-written popular news stories, these images help to convey these findings to a lot more people. In some cases, the work is selected to appear on the cover of journals featuring the article in question. And to me, that's kind of a rare treat. Not only does it help to massively increase the visibility of the scientist's work by being featured on the cover, but also to me, it helps more people to see my work, which to me is very lucky. So I do feel very fortunate sometimes to have my work selected to be on the cover of science journals like Science per se, or Current Biology. And yeah, so that's a very rare treat for me. Another major component of my work involves creating murals for museum exhibits. So this is maybe an even more immersive way to convey the findings of science to the public. Entire exhibits are developed around well-studied systems, And my illustrations help to visualize what these may have looked like when they were alive. Some of these organisms, some of them are life-sized images, such as these Mementosaurus at the National History Museum in Los Angeles County, or the opening day of the Deep Time exhibit at the Smithsonian's National Museum of Natural History last year. And so that was a huge project that I was involved in, the largest one to date, that involved 59 murals and panels for this wonderful new exhibit. I also illustrate books for children and adults. And this is an even more accessible way than museums for people to learn about science. And so I find it very important to make my illustrations as anatomically correct, as scientifically accurate as possible, because I want them to be sources of reliable education as well for children. To me, it's very important to educate children as accurately as possible, because they're going to be our next generation of policymakers and scientists and responsible citizens. So to me, this is a very important and I find very fortunate and gratifying way to participate. I've also found that illustrating books serves as an extremely effective way to help increase the concern of people for the natural environment. So a lot of the books have strong messages of conservation in them. And that way, it becomes yet another tool to help us to be aware of the beautiful diversity of life on Earth and to foster concern for it. There are also some really fun sort of spin-off ancillary applications of scientific illustration, such as this set of postal stamps that I was commissioned to illustrate last year for the United States Postal Service, featuring a very special Tyrannosaurus specimen, the nation's T-Rex, or the Wankel T-Rex, that is now housed in the Smithsonian's National Museum of Natural History, and that was opened to the public after revamping last year. And these are lenticular stamps, actually. So as you rotate them, the two images become visible on two of the stamps. And so they're kind of fun that way, too. And again, even in some of these stamp projects, I find it gratifying that there are conservation messages. So, for example, in this set of Canada's sharks that I illustrated for Canada Post Corporation, they help to highlight some of the endangered status of some of these sharks in our waters. For example, the short-finned mako on the upper left there is critically endangered right now. And so this is another interesting way for a lot of the public to become familiar with something that really needs a lot of attention. And both my wife and I have been involved in illustrating and designing coins for the Royal Canadian Mint. And this is an exceptionally fun kind of a project to do, where we illustrate what then appears on the reverse of the coin. So this one here on the upper left is the first one I did. It's a Pachyrhinosaurus Lacosti, and it actually has a glow-in-the-dark skeleton that appears on it. So these are a variety of coins that we've both done. Actually, you see a few of them in the auction for the festival here, including a meteorite containing coin that my wife Alexandra Lefort designed. And you may have seen a talk from her earlier on the search for life on Mars. One of the most direct ways in which artwork can benefit science is in these live painting events that I sometimes do in fundraisers for particular institutions or organizations, where the artwork is then auctioned off to raise funds that are then applied directly to conservation or research or education. You can actually see one of these paintings in the auction for the Huntsville Science Festival that I produced, and that is featuring a illustration of the moon of Jupiter, Amalthea, over its cloud decks. Sometimes there's even involvement from celebrities. So here you see Dan Aykroyd holding the key to the Peace Region, which was presented to him at the opening of the Philip J. Currie Dinosaur Museum in Grand Prairie. And you can see a picture of a Pachyrhinosaurus lacusti that I illustrated there. I was involved in creating the murals for this new museum, and Dan Aykroyd and his family were major contributors, which helped to make the museum a reality. Yet another fun way to interest people in science has been these online webinars on how to draw certain animals and plants that I host, along with organizations such as Sharks for Kids or Sierra Club BC, or even paleontological institutions such as the Yukon Beringia Interpretive Center. And this has been a very effective way to reach out to the public, kids and adults alike, because people love to uh, participate in these drawing workshops. And it's been especially effective during the pandemic when people have had to stay home a lot more and away from school. So I'm hoping that this ends up being yet another fun way that we can involve people in science and in caring for our biosphere. And when I get time, I like to create my own work that is not commissioned. So I have ideas in the back of my head always of things that I want to do. And, when I do have time in between projects, I like to kind of play around with it, and I create artwork that way as well. And in all cases, I like to integrate science into my work as much as possible. So I'd like to explain to you how I do that using a number of examples, in many cases involving both paleontology and planetary science. Here's a picture of a Megalosaurus I created for the Oxford University Museum of Natural History. The information for these illustrations comes from numerous scientific studies. And this is a picture that I created for a particular exhibit featuring a very well-preserved dinosaur called Leonardo, which is a Brachylophosaurus, a type of duck-billed dinosaur, that was mummified. And so we were able to reconstruct it at extremely fine detail. For example, the remains preserved the shape and distribution of different kinds of scales on its body. So everything from the fine pebbly scales on most of its on its back and sides to the larger, almost armor-like scales on the legs of the animal, which might have helped protect it from abrasive vegetation, to the leathery skin on its belly. Leonardo even preserved the its last meal inside of its stomach, and so you have the pollen from a plant community that it ingested, and from this and from other studies, paleobotanical studies, I was able to reconstruct a sort of a visual appearance of what its environment may have looked like at the time in Montana from a long time ago, about 77 million years ago. And this was featured in the exhibit Dino Mummy CSI, Cretaceous Science Investigation, at the Houston Museum of Natural Science. And so this is a fun way that we can then use science to help reconstruct entire ecosystems, not just the individual animals and plants that lived in them. So paleoart and scientific illustration can present sort of visual descriptions of events from the past. And now we come to a particular intersection between paleontology and planetary science in an event that is depicted in many examples of paleoart, and a lot of my own as well. The asteroid impact at the end of the Cretaceous period that ended the reign of most dinosaurs. And so this is a very popular one that I depict as well, all the way from scenes of the asteroid approaching Earth, like on the left, and then on the right, just before it impacts, with some of the meteor streaking in ahead of its arrival, to the actual impact at the very bottom here, which I created for the Manitoba Museum, seen from halfway below the surface of the ocean. And of course, the top one there is a very interactive type of piece of an exhibit for the deep ocean, sort of the deep time exhibit at the Smithsonian, the National Museum of Natural History, which, by the way, is a wonderful exhibit to visit if you have a chance. It opened last year. We can use scientific illustration creatively to tell the story of this impact, as I did with this set of illustrations for Mohamed Bazi and Nick Campione and his group, to show the impact, sorry for the pun, of the asteroid on marine community diversity. So before the asteroid impact, we have this very diverse community of sharks and a mosasaur in the background as well. It was a study on the shark diversity around the impact. Then here we see the arrival of some of the meteors ahead of the asteroid itself, and you can see the asteroid is a small crescent-shaped object in the image on the upper left there. And so I've modified the image to, or these parts of the image, to show kind of a story that's developing. And then after the impact, you can see that the sky is now full of a layer of ash and smoke from the impact. And the marine community is now relatively lower in diversity, as some of the animals have gone extinct following the impact and the massive effects that it had on the biogeochemistry of the Earth. And so we've lost a large component of the shark diversity as well as the mosasaurs. And in this way, I've used illustrations to kind of help to tell a story from before to after the impact. And this is yet another way that it's kind of fun to involve scientific illustration to help kind of inform the public about the work that scientists are doing to reveal how the natural world works. Of course, the impact of the asteroid 66 million years ago is not the only time that we would have seen impacts in the past, and I find it fun to find other events in the past that are rarely illustrated. So here we have a picture of the formation of the Tycho crater on the moon, which is one of the few things that you can actually see with the naked eye on the moon without telescopes or binoculars in some cases. And this happened about 108 million years ago, which can be determined by counting the craters on the moon and determining the number and distribution of the sizes of the craters to estimate the age. So 108 million years ago, you would have had dinosaurs and pterosaurs, and they would have seen this impact happen on the moon, which would have been an incredible thing to be able to see. Another process that's studied in a lot of planetary science and geology on Earth is volcanism. And so volcanoes are depicted in a lot of paleo art, often too many of them, so volcanoes didn't occur in all times and places. But one place where they did occur was in China during the Jurassic here with these pair of guanlong, which are tyrannosauroids, ancient relatives of T-Rex, which are courting to each other and are oblivious to this cloud of ash that's coming their way and might either bury them or their relatives in the near future. And some of them were wonderfully preserved as a result of being buried by that ash. Also, at the end of the Permian, we had the largest extinction in all of history, with more than 90% of species becoming extinct. This was largely the result of the eruption of the Siberian traps, an enormous set of volcanic eruptions that led to gigantic changes in the Earth's biogeochemistry and massive climate change. And of course, one of the most colorful planetary processes with which a lot of us are familiar are northern lights, or aurora borealis, or the southern lights, aurora australis. These, of course, are when charged particles from the sun spiral in along the field lines of the Earth's magnetic field and hit the Earth's atmosphere and begin and then knock out electrons. And of course, you have a lot of this beautiful glowing light resulting. And this is really nice because I can use it as an additional source of illumination in some of my images to show night scenes, which are otherwise quite dark. So this is a picture of a set of mastodons that I created for the Yukon Beringia Interpretive Center in a study by Karpinski on the very interesting migrations or the movement of mastodons across North America between the ice ages. So yet another way in which these planetary processes can make for some fun and interesting ways to relate science to the public. Although I do mostly paleo art, not all of my artwork features paleontological subjects. Sometimes I just like to do space art. And so, for example, here is a picture of Jupiter on the left with Amalthea hovering above its cloud decks in the foreground. I love Jupiter. I love the gas giants because they have these wonderful, complex-looking cloud formations. And to depict moons in front of them is always a fun thing. And so on the right here, again, you see that original acrylic piece that I provided to the auction at the Huntsman Science Festival. And it again shows the small potato-shaped moon Amalthea hanging over the cloud decks of Jupiter. Saturn is another one of my favorite subjects of space art. Not only is the planet amazing with its ring system, but it has one of the largest moons in our solar system. Titan has an atmosphere that is twice as dense as Earth's, and it has lakes or seas of methane and ethane with these strange waves with different physical properties from water. And it's extremely cold there, but of course it's below the temperature of boiling of these organic compounds. And so you'd have a very strange scene with the sun and Saturn overhead in these smoggy skies with these odd oceans or lakes and seas of methane and ethane. It makes for some fascinating and really fun artwork to create. Not only that, but there's actually a liquid cycle or an ethane-methane cycle, just like our water cycle on Earth. And so you have rain on Titan as well. And so it must be a really strange thing to be able to see rain of ethane and methane coming down on Titan in this extremely unusual environment. And scientific illustration is also helpful in helping us to visualize things that we can't see because they're too far away or at a different time, like I was mentioning before. So for example, here we see Betelgeuse, a gigantic supergiant star, with a depiction of a giant star spot on its surface, which is one thing that was that might help to explain why it dimmed so suddenly over the course of a few months, over the last a little while recently. The star spots have a lower temperature, just like sunspots on the sun, and because of that they emit less light and may have explained why it dimmed so much. On the right here, you see the red giant phase of the sun a few years down the road at a very roasty, toasty time that we can't observe because it hasn't happened yet, but we know it's going to happen and will ultimately engulf the Earth and Moon as well. So another fun way for scientific illustration, in this case space art, to kind of take us to places and times that we can't observe directly, or at least not in much detail in the case of Betelgeuse. We also know from numerous studies of the orbital dynamics of stars that there are hundreds of planets out there beyond the sun orbiting other stars many light years away. And some of these are really quite wacky environments. So this one here, the planet with the really creative name of, or very interesting name of HD 149026b, it orbits its star very closely. It's a gas giant that it's very black in color, and so it absorbs a lot of the radiation that hits it. It absorbs so much that it glows with heat more than it reflects the light. And so this planet is a strange one and a fun one to illustrate because the side of it that faces the star is actually glowing red hot. And here we see it from the surface of a hypothetical moon that has a lot of tectonic activity because of effects of gravity as it orbits its planet. That's a hypothetical moon. We don't have evidence for it, but we can kind of use this as a way to depict the planet from an imaginary location in space that is plausible nonetheless. And speaking of the hypothetical, sometimes I like to take my work way off to the edge and to try to imagine things that science has certainly not yet discovered. So I've always been, as I mentioned, interested in the possibility of life beyond Earth. And although most of the life beyond Earth that we would expect is probably microbial, it's very possible that life on some places, Earth being a really good example, a very real example, may have evolved beyond the point of single cells and to form multicellular life. It would be amazing to imagine what the communities of life might be like on other planets that have these ecosystems. What does life look like after having evolved to solve certain challenges in their environment? So I love to play around with this in my mind and to join sort of the speculative creative imagination with some of my ecological background to try to project what evolution may accomplish on other worlds. And this brings us back to Earth, and along the ideas of the hypothetical, I love to use scientific illustrations sometimes, even when not reporting on a particular discovery, to just kind of spur creative thinking in science. And so, for example, we have amber that has preserved pieces of animals, including pieces of dinosaurs, birds and otherwise, even non-bird dinosaurs, in them. And we have large enough pieces of amber that could, in theory, house entire animals in them, of small dinosaurs or young dinosaurs. And so, hey, who knows? Maybe someday we'll find an entire, like, this depiction of a young T-Rex hatchling that had stumbled into a pool of resin large enough that became a large piece of amber later. We don't have this, but you never know. And so it's kind of fun to play around with these images to try to kind of spur interesting ideas. So with that, I'd like to thank you very much for listening to my talk and for letting me sort of ambush you with all of this information. It's a great deal of fun, and I am very lucky to be working with the wonderful people that I do, collaborating with scientists, with other artists, and with sharing this with the public, and to be able to do these kinds of presentations like at the Huntsville Science Festival. So thank you very much for your attention.